Hey there, welcome back to the channel. My name's Chris, and today we're going to continue with the Varister project that I've been working on. We're going to try our hand at making a PCB. This should be a very straightforward, simple two-layer PCB, so it's a good place to start. So let's get into it. The tool I'm going to be using here is EasyEDA. There are definitely other tools online. I don't have any specific, affinity for this other than I've used it a few times. One of the nice things about this is it allows us to draw up the schematic, convert that to a PCB, and directly from it order our boards at a really, really low price. So that's the reason that I'm going to go with this. If you choose something else, that's just fine too. So the first thing we need to do is obviously create a new project. So we will go new project, give it our name, and save. That's going to open us up onto this, empty sheet. The first thing we want to do is we want to build our schematic. So we're going to draw out the schematic for the Varister. The intent here is we're going to create just a microbus board that plugs into this header here and basically replaces all of these wires and provides us a place to put this chip. And in fact, we're going to design it with two of those on there, and then maybe some screw terminals like this on it as well. Something, pretty straightforward. So this initial one, that's all it's going to be, is a board that plugs onto here. We will continue using the project lab and continue using this display and inputs and all of that. So it's just going to be an expansion module for this. My intent is after we do this, then we will move on and maybe make something a little bit more robust that is a standalone. But for now, let's worry about just creating a real simple PCB. So the first thing we know is we're going to be connecting onto one of these microbus connectors. So let's go get one of those. We can come over to the library, and I'm just going to search for microbus. Now, right now we're set up to search in system, and there are two of them here. The important thing here is when we're looking at components we want to place, we want something that has this top part here, which is the schematic, but we also want a PCB layout, so something down below. Both of these, the PCB layout, see how it has this purple line around it? Let me zoom in for you. See how it has this magenta or purple line that goes around it? It's the border around the PCB. That would be great if we were going to make something that is that size. Since we're going to be likely making something a little bit larger because we want to put two of these MCPs on there, this border is probably not big enough. And my experience so far, admittedly it's limited experience, but my experience is that if you've already got those borders on there, changing the size of those becomes a real challenge. So my suggestion is look for something that does not have them if you need to do a custom size. So if I was going to lay something out that fit into this, this would be a great option. So I can come over here to this user contributed, and then I've got a whole bunch of other ones. And so this one, it's nice. It's got the schematic, but it does not have a PCB layout, so I don't want to use it. Same there. So we can scroll down. This one has this, and it actually looks like they've got an outline, but it's not that purple color, so it just does a drawing of the lines, but not an actual border. So I'm just going to scroll down. Now this one's not bad, right? So it has some silk screen that says microbus and the pin headers and labels for each one of those. So that's not too bad. Similarly here, this one's a little bit less noisy. I kind of like that one. So just kind of scroll through, find one that you like. I kind of like this one. We'll use that. In fact, I'll remember it. So if I put that little heart on as a favorite, it will show up in my favorites. So then I'm going to hit place, and I'm going to just place this on the schematic. Now the next thing, if you recall from my previous video, I used an MCP 4162. It's a through hole dip size, and I'm going to stick with a through hole component on this. I can already hear my coworkers, rolling their eyes and laughing at me that I'm using through hole instead of a surface mount. But there's a method to my madness. I want to do through hole because, first of all, it's really easy to hand solder, and I don't want anybody that's following this, if you don't have like a hot plate or anything else, to be able to still build one of these, because I want to show assembling this as well by hand. And really, for the first pass, that's all I'm after, is something that's functional. I may go through and redo this in a future revision with surface mounts that will allow me to get a few more components on. For this, it's very, very simple, so we'll just use all through-hole components. So again, we come over to our library, and we're going to search for the MCP 4162, so just search for your part. And this time I'm going to go back to System. I tend to like these a little bit better. And you can see here, this one is a dip 8, so this is the through hole, as opposed to something like this, which is a surface mount version. So we're going to go with the dip 8. So this is a through hole, and we're going to place. I'm actually going to place 2 of these because I think we've got room. And really the only other component, if we come back to the data sheet, we look at it, they usually have recommendations. You can see right here we've got a capacitor on the power line. And it's a 0.1 microfarad. So if we come back here, we're going to go to our library. Now the interesting thing here is, since I'm doing a through hole, it really doesn't make a whole lot of difference. I just need to find something that's got a pair of holes that I can run to. You can go out to Octopart or DigiKey or something like that and get a part number for the specific capacitor that we're going to put on and drop that on. So let's just go through that process. So we come over to the DigiKey site, and I'm just going to put a 0.1 UF capacitor. And it's going to give me lots and lots of options. I'm just going to choose an electrolytic capacitor. Simple enough. So you can see they've got 4,000 of these, 7,000 of these, whatever. I usually take a look at the price and to see if I can buy them in individuals. I undoubtedly already have some of these, in my rack back here, but this will at least give us something that we can go with. And again, this is how you would search for any part. So I'm just going to grab this part number, copy it, come back here, and paste this in and do a search. And of course, nothing comes up. There, we found one. This is a 0.1 microfarad radial capacitor. I select it. We've got both a symbol and a PCB layout. We can take a look at both of them. We can either put a polarized or a non-polarized. We don't need it to be polarized. So let's place that, and we need 2 of these. These go onto, again, the VDD. So I'll just put one here and one here. And so that is, in fact, all of the components that we need for this. So now all we have to do is lay these out with wiring. So we know we need power, and we were powering this from 5 volts. So I'm going to put 5 volt here, and we're going to put 5 here, and 5 here. Now these, to make my life a little bit easier, I'm going to rotate these. And you'll see why here in just a second. It's going to make life a little bit easier. When I take power, these labels are really long. You can go ahead and trim them. You can move them around, get them out of the way. Something like this. Then we have a ground. And here. And then I hit W to wire. And so what I'm going to do is I'm going to take power from 5 volt and it connects to the VDD. So you can see that. And then we're going to come out of here, connect it also to the power, and then VSS on this is also the ground. So we can come out of that and connect. This uses the SPI port for data in, data out clock. So we can hook those up. We know, and rather than running wires from these, which is MISO, which stands for master in, slave out, so that is the peripheral out, we could run this over, down, over, and up. It starts getting a little bit ugly if we do that, especially since this one needs to come over to here. So what I'm going to do instead is I'm going to delete those, and I'm going to use a net port. And as long as the net port names match 2 locations, it basically is a virtual wire between them. So if I let's put 4 of them on here for the 4 SPI ports. This is the chip select for only a single chip, so we're going to call this chip select 1. Helps if I use a 1. And this one is controller in, peripheral out. Controller out, peripheral in. Then I can just copy these, drop them here. So this one, this is the data in, and this is controller out, peripheral in. And our clock, our chip select. Then we rotate that around and connect that there. So now we've got, for this, we have our wiper and our end. So the resistance on this will be between these 2 pins, and we're going to bring that out to, again, a screw terminal. So let's go find a screw terminal part number. Single level, and let's do a 4 position. We want stuff that they have in stock. And we want through hole. And let's just take a look at those options. The one thing we want to take a look at here is the pitch. I don't really want a 5mm pitch. I'd like something a little bit smaller. Let's say a 200 mil pitch. Something like this looks really good to me. We'll copy that part number, and hopefully they will have this over here. I kind of like this one. So we'll place that there. Again, I'm going to use some net ports for this. And we'll call this resistor 1 wiper and resistor 1 base. And we'll copy those, hook that up to the base, and this to the wiper. So you can see here that all of the pins on this MCP are connected, and we have this recommended capacitor on our power. So really now I just need to copy what I've done here to this second one. And in fact, I'm just going to remove that. I'm going to copy this whole thing and paste another one right here. So now I have two of them. Now, one thing we have to do is we want the chip selects to be different on them. So I'm going to change this one to chip select 2, and then I'm going to copy it, and I'm going to hook it to another pin on this microbus port. I'm just going to use the reset line. The nice thing is on the project lab board, we've got access to all of those, so it doesn't have to be used as a reset. It's just called the reset pin. So when we wire this up in code, we'll know to use the reset line of that port. All right, so now we need to get the wiper and base. Call that a 2. And hook them onto this screw terminal. All right, so we have 2 of these. They're all wired up. They're wired to the microbus pins, and they're wired to this screw terminal on our output. So really, we're done with the wiring. That's as simple as it is. We do have a bunch of additional pins here that aren't connected to anything. Oh, one thing we did miss. Need to connect ground to there, and I'm going to connect this one as well. So we'll have the grounds, both of them hooked to the ground plane, which will then connect over to those 2 chips. All right, so now we have the 3.3 and several other pins that aren't connected to anything, so we want to make sure that we specifically say they're not connected. Otherwise, in fact, I can show you the error we get if we try. To make a PCB, we say convert, and then we're going to say, so what it's going to do is going to check the nets. The nets are the names of those signals, and if I say yes, check, it's going to say, hey, you have a whole bunch of these things that aren't hooked to anything. And you can see that these match these pins on this connector that aren't hooked to anything. So we'll collapse that back down, and we're going to put these not connected. And in fact, I see another problem that I did. Not connected here. All right. I have these connected to a net called 5 volts, but that is not actually connected to the connector. So we will, actually we've got it already here. So we'll just hook a wire from it to here. And we can go convert schematic to PCB again. This time it didn't even ask, it just connected it. I'm going to go ahead and apply this. Here, it's got a silk screen for those connectors, and we know that those silk screens match pretty well. So what we'll do is we will use the outlines of that silk screen for our board dimensions. That'll be the easiest way to do that. Going to change the units to mils and change the grid size to 50, and I'm going to change it to dots because that's much easier to see. So this purple is the boundary of our physical board. The yellow lines here are things that are predefined to be drawn on the silk screen. And then you can see all of these other things are the connectors. So what we need to do is we need to lay these out physically where we want them. Then we'll adjust the dimensions of the board itself to match it. And then we'll worry about running the traces on the PCB, so the copper between all of these pins. So the first thing I'm going to do is I'm going to take this microbus connector, And I'm going to put it up here. We said that we're going to use that as the guide for our dimensions. So I'm going to give it a little bit of a border there. And then I'm going to take this and I'm going to bring it in. Now you can see that these labels are off the board. Well, we know that these are not connected anyway, so we could actually change these to better reflect what we actually have going on. So this would argue for using a different schematic symbol. I just was not thinking about it when I did this. Now I'm going to go through and change the names on these to what they are in our actual schematic, our actual circuit. So a lot of these are just not connected. Bit of a mess there, but we got it all figured out. Next, I'm going to move our connector. And now our 2 chips. Now we know that the power needs to have that capacitor by it, and it needs to be close to it. I'm actually going to rotate those. Right now I'm trying to move things around so they're not overlaying this microbus text, which tells me again I would probably try to avoid using that because it's kind of frustrating and in the way. All right, so I have those laid out. Now I'm going to move the labels around. So now really all we need to do is wire these together. The first thing you want to start with is your signals. So in our case, our signals are our SPI bus or SPI bus. So clock, data in, data out, and then we'll do the chip selects. Let's do this chip first. Hit W for a wire, and we know we want to come from here to there. Now we also need to connect to this same signal here. So next we need to connect this SIPO here to here and up to here. The challenge that we run into is we can't run it directly across here because we'd have to run across this red line. We don't want to cross the wires. But this is on the top, so we can, because this is a 2-layer board and all of these are through-hole components, we can actually run to the bottom, and then I can connect a wire from here to here, and from here. Now we can connect it here, but we can't go through this pin because it is also a through hole, so we need to go around it. So let's just come from here and like that. Now our clock line, our challenge here is the clock line needs to go from, say, this pin to this pin. We can't do it on the top because we would hit this one, and we can't do it on the bottom because we'd hit this blue line. So what we're going to have to do is we're going to have to use what's called a via to go across it. The net name is SCK, so we're going to create a via. We'll start there. We're going to change its name to be on this. And now if we run a wire on the bottom, we can come from here to the via. We still can't do this because we're going to run into, if we are on the bottom, we're going to hit this, and if we're on the top, we're going to hit this, so we have to come up with a better way. And in fact, I think what I'll do is I'm going to take this red line, this wire, and move it above the pins. So now I can run on the top layer from here all the way to there. So now we have our clock. So now we have to do our chip selects. And of course, these two are crossed. There are a few different ways to do this. We could just swap the chips around. And in fact, that's probably the easiest way to do this, but let's see if we can do this without. I can come from this chip select 1, and actually I can come around here. This is on top, so we have to go under it and then come back up. So we are doing chip select 1, so we're going to do a couple of vias. I've mentioned that this is not my day job, right? Okay, so now we need our other chip select 2. From here down to here. And of course, we have the same problems where we've got a bunch of wires in the way. Yes, this is ugly, and I'm sure people that do routing all the time would look at this and go, what the hell are you doing? This capacitor needs to be closer. So I'm going to move it over to here. The decoupling capacitors, you want them to be, there is a specification, they're supposed to be within, I think, something like 4 or 5 millimeters of the component. The idea is you want them as close to them as you can really get them physically. So now, the next thing we want to do is I'm going to connect the wires to this header. This one is easy. I'm going to run these close ones on the bottom. I think really the only thing we have left are our power and grounds. And those we actually aren't going to run wires for. We're just going to use a copper fill on the top and the bottom. So we can do a fill with here. And I'm going to connect the first one, I'm going to do 5 volt. And so you just define the corners and it's going to fill it in. So I basically just lasso this whole thing. And it fills in this whole area. Now I can go to the bottom. I'm going to hide the top, and I'm going to do a fill with ground, and that fills the bottom. Show my top again. So this is the top. And you can see if we zoom in, it connected to the 5 volt here and onto the capacitor. And it did the same thing here. It's connected to the capacitor and to the 5 and to this header here. And then if we look at the bottom layer, it similarly connected those to all the ground pins. All right, so we take a look at our board. I believe everything is set up. We can take a look at the design manager and look at our nets. And it shows all of these. And if we look at any design rule check errors, so if we didn't have something connected, it would show up here in the DRC errors. So we actually have everything hooked up. We've got all of our components laid. So really now the only thing left to do here is to put some silk screen. Let's put our text. And you can change the font if you'd like. It's always a good idea to put a revision on your board. So something like that. So I'm just double checking, making sure nothing is obviously in the wrong spots, nothing too close to anything else. This via probably wouldn't hurt to move over just a little bit. Now I've moved it. What I can do is I can now click over here and I'm going to rebuild all of the copper, and it filled that little gap in. Let's make sure that that bottom layer is still connected. It is still connected between those two. Our nets are still good. I'm going to refresh. So we do have an error. It doesn't like... so I moved it over here, and now it's too close to that. Whatever that line is down below. This one. So let's hide the top. We don't want those connected. Show the top again. Okay. Let's rebuild all the copper again. And now let's refresh. Okay. And it says we are missing a ground connection. So it appears to have lost our ground. So we're just going to re-pour the ground copper on the bottom. All right. That was painful. Again, this is the first PCB that I've ordered. Let's look at the design manager again. Refresh. All right, we have 0 errors. We have all 11 of our nets. Let's refresh that as well. They're all there. If I look at the board, let's look at the top. Let's look at the bottom. Nothing's standing out as a problem. All right, so now we are going to order one of these. First, we need to create our Gerber file. Guess we got to save. Let's save. Now we're going to say we're going to one-click order our PCB. So it's going to ask, do we want to do the design rule check? Yes, we do. And it's going to ask questions like this. We can always adjust these. Let's go with, I don't know, how about black? Always pick the minimum quantity because, well, it's the first run and I'm not certain that it's going to be correct. So then I'm going to go here and place this in my cart. Click on this and it'll take us over to the cart. It's going to process the Gerber automatically. All right, so now it's going to ask a bunch of things. I just want a standard PCB. I don't need a flexible or aluminum or copper core, any of that. A standard 2-layer board. Quantity, I'm just going to select 5. We don't need aerospace or medical, so just a standard industrial. 1 design, single PCB, 1.6 thickness. Basically, I'm just going with all of the defaults. Now, the surface finish, we do not want Hazel. We want lead-free Hazel or Enig. The Difference is this Enig are gold, whereas the Hazel are silver. And if you've seen things that you order like this, see how that's silver? That is this lead-free Hazel. Whereas the gold ones I think are a little bit easier to solder. They are also a little bit more expensive. You can see right here the calculated price is going to be $18 for the more expensive, and if I go with the cheaper option, $3.10. Well, it's $18 for shipping. So the difference, you can see it's a significant price difference. $3 versus $18. If I'm honest, I don't really know a whole lot of the difference on these. Like I say, it's this gold plating. I'm going to go with the gold plating just because. Everything else I'm just going to leave at the default. So I'm going to save that. And now I can go over to here and I can do a checkout. All right, so they're ordered. Cost me less than $40 for 5 boards. They're going to be coming from China. They're already in production. They should be here in, my guess is, a week to 2 weeks. So my time, it'll be about 2 weeks. Your time, it'll be about 2 seconds. They'll be here, and we can take a look at what they look like physically and solder them up. All right, we've received it. Let's take a look and see what's in it. You know, on first inspection, they look pretty nice. All right, I'm going to take these over, solder on some components. This video isn't intended to be a soldering tutorial. If you're interested in something like that, go ahead and leave a comment down below and we can do it. But otherwise, I'll be right back. All right, so here we have it. Couple of things I did notice when I was putting this together. You can see it's got this long label. Let me find something to point with here. It's got this long label in the silk screen for this microbus layout. I should have removed that. The capacitor labels. This one is basically up is this direction, and this one up is the other direction. So I kind of didn't standardize these. Whatever. It's not a big deal. The one thing that it would have been nice is these connectors over here, the screw terminals. I didn't have any label on those, so there's not a label for 1 and 2. I should have probably done that. Another thing that probably would have been nice on this is just a white square or something on the silk screen that I can write on, because I put some, I think, 4142s on here. At any rate, it'd be nice to have something on here that I can write what part numbers that I actually put on, so that when I have several of these laying around, it'll be easy to tell. Bunch of minor things, though. Otherwise, everything went together just fine. We can just stab it down on here. Fits nicely. Again, you know, the silk screen on the Project Lab up is that direction, and then you can see the label here up is that direction. Again, not a big deal, doesn't affect functionality, but just to be complete, would have been nice if that was all the same. Let's power this up. There we go. Once we're up, see if I can focus that a little bit better. So it comes up. Both of them are mid-range for a 5K. Up and down, I can select which resistor it is. And I can adjust, say, 1 up and 1 down. And let's grab the meter. $3K. And 1.47 for the second one. It's a little bit off, but again, that's just because of the resolution. This is only, I think, the 8-bit version. you can see it tracks pretty well. The value you see here and the value you see here, this is not measured. This is computed of what it should be based on the number of steps and the part number. So there's probably a plus or minus, say 5% or something like that as well. All of the hardware seems to work, so there we go. We have our first board. I'd like to do another one that has support for 4 channels. These only have a single channel in each chip, but I can move to a surface mount. It's about the same size and it has 2 channels. That would give me 4 on one board, and that would give me 4 out here. The reason I would like 4 is I want to simulate some gauges for a car, gas, oil pressure, temperature, things like that. And that's how most automotive sensors work, is they just act as a variable resistor. So this can simulate those, and I'd like to be able to do 4 of them on one board. The reality is I could just take 2 boards and I'd get 4 on here anyway, but it'd give me an opportunity to try a different layout and to try my hand at surface mount components. Otherwise, that's it for this project. Thanks for watching.